I'll try to project my voice across. And so, yeah, let's find a problem from the textbook. I think, yeah, I was doing this. I tried to open up the textbook and nothing happened. Let me try that again. Oh, I guess, I don't know, maybe I didn't click hard enough or something. I'm going to grab a problem out the textbook, and we'll do it, one that's difficult that we have to use that technique for. Well, not have to, we don't want to do trial and error forever. So we're in section 1.6, I'm sorry. 1.5 we did do. 1.6 we didn't finish. This online, though, has different numbering to the sections. So 0.5 we did do. 0.6 we were working our way through, that's factoring. And let me just go right to the exercises and grab one of these guys and work it out using our technique that's all involved with the, instead of trial and error. Let's see if I can find a good one here that has too many choices. I don't like any of these. I'll make it up myself, I guess. I don't like any of these. These are all bad. Nah, just joking. I'll make one up. Okay, 12x squared minus 3x minus 9. Oh, wait. That doesn't work. I don't like that. Alright, that works better. 12x squared minus 8x minus 15, right? Reverse engineer. Wow. I'm writing one place, showing up someplace else. That's it. Really? Oh, geez, dude. Sorry. I forgot I have to do this at the beginning. I was like a right boy, right? Minus 8x minus 15. Alright, so, yeah, and the directions will say factor. First, actually, take a look at it and see, make sure you can't factor anything out before you even start. And numbers don't share anything common. It looked like the 12 and 15 shared something, but then the 8 doesn't share that same thing, so it's not going to work out. You can do trial and error. I think eventually you'll get to it. It might take some time. And so what we'll do instead is we'll try this technique that will kind of always work, even if it's x squared in front. And here's how the technique works. I made a video of this too, of a problem like this. I made a video for some other class, maybe in some other university. I'll post a link on our G2L of that video of me working out the problem, talking you through exactly what we're doing here. But here's how it starts off. Take the first term and put it in the upper left square. Take the last term and put it in the lower right square. Okay. coefficients 12 and minus 15, negative 15. Take those two numbers, the first coefficient and the constant term, multiply them together. The problem is that in this, it's going to get kind of big. Okay, 12 times 15. 180. All right. So we have a negative 180. That's going to be a large number. Our goal is, though, to make it a riddle like the other ones that we can actually work our way through and solve. I need to come up with two numbers that, instead of multiplying for the exact last here, negative 15, now they're going to multiply with this new number that we made up here by multiplying those together. All right, that's a big number. It has many factors, but we'll be able to work it out when we figure out that when we go and put them in, they have to add up to be exactly the middle term of negative 8. Okay. So in words, I need two numbers that multiply to 180 negative. And because that's a negative, they're going to end up subtracting to negative 8. Basically, they're 8 apart from each other. When I write them out, don't worry about the positive and negative to the very, very end. And so the problem is that 180 has way too many factors. Okay? And you shouldn't have to list them all. If you want them to be 8 apart, then try to get the ones that are close. Like, probably you already have it, right? You already have it? Try to use 10 whenever you can. Here it's exactly what you need, right? 8 apart from each other. The goal is not to make this exhaustive list. You'll be there forever making that list. Okay? Make the list, but make it smartly. 8 apart. This is exactly 10 and 18. When you get the numbers that satisfy this riddle, then you worry about what sign. So I have 10, I have 18. Who gets what sign? I know one's going to get positive, the other's going to get negative. How do I decide who gets what? I need the result to be a negative 8. So who gets the negative? Negative 18. Great. The bigger one gets the sign of that number. When you do these numbers, now that you have them, you take them and you put them in the other squares that are left over. Here's one key that's kind of weird that you wouldn't think to do. Attach on an X to these guys. Because they're like the middle terms combining together. Doesn't matter who goes where. You know, do however you want. I'm just going to put the 10x down here and the negative 18x up here. And the hard part is done. Actually, the way of making that list up smartly, that was the hard part. Following the method, like following the steps, the recipe, that's not the hard part. The hard part is that part we just did. Come up with those two numbers. Now, we're going to just be careful not to make a mistake. Factor every row and every column. Find out what these things have in common and just take it out. And you'll be a couple steps away from the answer. What do the terms 12x squared and negative 18x have in common? Number-wise, what do 12 and 18 share? A 6. You want to take out the biggest thing. Yes, they share a 3. Take out the biggest thing. The greatest common GCF, greatest common factor. But they also share an x. And always, when you're setting up this method, in this spot and in this spot, you'll be also taking out an x. Because the way we have it set up, you're guaranteed to have that first row and that first column always have an x in common at least. Maybe more than just an x. Okay? Second row. 10x and negative 15, what do they share in common? 10? 5. That's good. That's good. Okay? First column, 12x squared and 10x. A 2 and an x. Very good. And then finally, here's the one extra thing you have to remember. If they're both negative, take it out as a negative. And 18 and 15, 3. And you're done. When you can write this, then this is how it's going to factor. In parentheses, 6x plus 5, 2x minus 3. I mean, you might have been able to come up with that trial and error. It might have taken some time because of the fact that 12 can be broken apart as 6 and 2 and 3 and 4. You might have tried 3 and 4 first and you wouldn't have gotten anywhere with that. 12 and 1 you might have tried to break apart the 12x squared. But anyway, this technique there's no guessing. As long as you can follow the recipe and be careful not to make a mistake, you're going to get to the answer. You don't have to do this at all. Someone taught me this and I just thought it was useful. So I had students that were struggling with factoring and with enough practice, they got used to this, and they were able to, factor stuff that they could normally just be all day trying to factor. Okay? And I'll put a link to a video of me doing exactly that same kind of problem. Not exactly this problem, but I'll put a video up so you can just see it again and watch it whenever you want. And this video of this class, it's recording? Yeah. And the video of this class will go up so you'll get to see, if you want to watch it again, us going through that same example. Question in the back? Is there a way you can check your answer and know you got it right? Spoil it out. Multiply it out. The thing we did in section before this, it was called R1.5, or in the online book it was 0.5. We did the backwards of this. We would take and we would multiply out and get the answer that the problem starts with. So we go ahead and FOIL F. We get 12x squared. O, we get negative 18x. And you see that you're getting the elements that are inside of this thing along the way. 10x and negative 15. So you can check, you can know your answers right or wrong. You can grade your own test. If you have the time to go through it. Combine the middle terms to give you the negative 8x. Very good question. Yes, you can combine. You can check your work. Whenever you come in late, just remind me at the very end to check you off on the attendance, because I do it right at the beginning or 2 or 3 minutes into the class. So just remember that. Next time around, it'll be a sign-in sheet. So just remember you get to that sign-in sheet before you leave. If you ever have to leave early, that's fine. Just sit here in the back and quietly just bounce whenever you need to. Good? More questions? We're good? Yeah, I couldn't find any good ones in the book. I had to make that up, but I think that's good. All right, so try the homework. I have a bunch of problems already picked out from the last time I taught this class. By no means is all that due. You get to see it now, I think, but you don't have to do all that now. If you go in as a student and log on, it's good. 24 of you have done it, and this class has like 40 in it, so I'm happy with that number. I want more, though. I want more students to register. If you ever forget how to, there's a link here, online homework setup in our D2L. When you get to D2L, you'll have these links on the side here. I think I picked the right link. Yeah, 81 is our section number. And then the only thing that matters to you is the content and the grades tab. So content, that's where everything is going to be at. Syllabus, online homework setup, the notes, the videos, everything will be right here. So go on before next class, if you can, set this up. And as a student, you'll see something that looks like this. It's free for the first few, I don't know how many more days it's free. Oh, wow, only 4 more days. And then you have to pay for it after that, yeah. 48? Anybody do this already? 45. It's not bad. And the book comes with it, right? Or no? With the book, it's 80? 75? Not bad, not bad. And this first set of homework is due by our target date for our first, I want to call it an exam, but officially it's like not really a full exam, so I call it a quiz. So our first quiz, our first sort of test is over the material that's there, and if all goes well, it'll be on that day. So what I did is I took the whole chunk of questions and made them due on the start of class that day. What'll happen is you'll just come in and just take the test. I mean, I'll open it up again for questions at the beginning. You probably won't need the whole, time to take the test. I'll give it to you though if you do need it. But yeah, that's what's going to happen basically. The chunk of sections that are sort of on each exam will be due the day of that exam. So if it happens to be that we're behind and I have to move that exam, I'm going to move that homework to be pegged to the exam. More questions, please. Logistical and mathematical. We're good? Yeah, Tim.
I don't need to see it. I just need to know. Would that method that you just used, would that work if you're trying to multiply a monomial by a trinomial?
If you're trying to, okay, so if you're trying to multiply, his question is, if you're trying to multiply a monomial times a trinomial, this method that we just did, will that work? And the quick answer is that this tool, this technique, is used for factoring a trinomial into two binomials, but a quadratic, not just any random for factoring quadratic. This is for factoring quadratics only. What you're talking about will be going backwards, and we did see a technique for that. Let me just quickly do that. You said a monomial. What'd you say? A monomial times a, what'd you say?
Trinomial?
A binomial and then trinomial?
Just a monomial.
Oh, monomial. Okay. Like, a monomial is a single term. These words we're throwing around. Monomial is a single term, like 5x squared. That's a monomial. And a trinomial has three terms to it. 3x cubed minus 6x plus 8. Trinomial. And his question is, okay, if I multiply a monomial times a trinomial. Now, this isn't factoring. Section 0.6 is factoring. Section 0.5 is the multiplying, adding, subtracting polynomials. Not dividing. We won't divide yet. It's coming up. Dividing is coming up. So this is kind of a 1.5, or 1.5, or online homework 0.5 on online text. So multiply this out. Maybe the directions won't be as explicit. Maybe they won't say multiply. Maybe they'll say just perform the operation, and then you have to know that when you write something next to a parentheses, implies a multiplication. But anyway, just FOIL, kind of FOIL, but not really FOIL though. When we did that to check to make sure, this worked, officially we did FOIL, right? F, O, I, and L, right? But what that is basically taking the things that are on the left and multiplying them by the things that are on the right. And so I like to think about it just distributing. I don't know if you don't have to tie that word FOIL to it. It isn't always the right word to tie to it. So we're just going to multiply that through. Take 5x squared and multiply it by 3x cubed. Take 5x squared and multiply it by negative 6x. Take 5x squared and multiply it by 8. In between these, make sure you put a sign. As long as you take the sign that's with it, then you just go ahead and put plus signs. So this is not as complicated a question than that last one. This is more straightforward. Numbers times numbers, variables times variables. What do you do with the exponent? Add. There you go. So I have 3 times 5 to give me the 15. And x squared times x cubed to give me x to the 5th. Add them together. You know, if you get stuck and you don't remember, just think about what it is, right? X squared is x times x. X cubed is 3 of those guys. Well, how many do you have altogether? You have 5 of them. Okay. And then finally, these other ones, you could plus a negative if you want. Usually you don't see them written next to each other like that. Usually plus a negative will translate into subtraction. But 30x cubed and what's that? 40x squared. So that would be your answer in final. 15x fifth minus 30x cubed plus 40x squared. That would be an answer to that question. Monomial times the trinomial. 4 questions. We didn't quite finish the factoring section. That's what we're going to pick up. There's some special kind of factoring that we're going to do next, but we got the basics though. We got the standard factoring and then the more complicated factoring where we have to get more involved. I did open a textbook and I saw some, but I didn't really see ones that really jumped out at me. I did see a few that I wanted to look at. What generally happens with this textbook is that there's a bunch of kind of basic problems, and then they get to some kind of applications, word kind of problems at the end. But I want to make sure definitely that you can do the basic problem before we even think about applying this to some fake kind of a real life problem. So one of these that jumped out at me, just real quick before we move on, is, so don't be discouraged if you see something higher than quadratic. so far what we've been talking about is factoring quadratics, but it could be more than a quadratic, right? Take a look at 46. 12x cubed. That's not a quadratic. That's called a cubic when it's, highest power is a 3. That's not a quadratic. But don't be discouraged. Don't think that you have to come up with some new kind of technique to factor anything higher than squares. I just want you to be able to factor the squares. And so it must be something else that's going to help you out. And let's take a look at 46. 12x cubed minus 48x. So first we're going to do something that will turn this into a quadratic. 12x cubed. This is on the online text. Minus 48x. So at first you get discouraged because you see a cube. It's not a quadratic. But what you should do is, directions, they don't tell you. They just say factor completely. And it's not very obvious what that means. Why did they put that extra word in there, completely? Why did they just say factor? What do they mean by saying completely?
Do they want you to take a GCF off first?
Take something out first. Whenever you say the word completely, that's like a hint that there's something more than just factoring, like normal factoring. Factor out a common factor. GCF, greatest common factor. Yes, we can take they definitely share a 4, right? 12 and 48. 4 goes into both of them. But you want the greatest common factor. When they say completely, they mean don't just take out something, take out the biggest thing, and then worry about what's after that. So it's not just a 4 and an x. What else? 12 goes into 48. If you don't see it, just try what you think. If you see 4, then try 4. And then you'll see there's still something left. Say you see 4. I see that they share a 4. Well, fine. I take that 4x out, but then I'll see that what's left over still has some stuff in common. And I just got to do an extra step because I didn't get the greatest one. That's okay. Maybe you don't know that 48 is divisible by 12. Maybe that's not quick like that's okay. So you have to go through a couple steps if you don't see it. Take the 4 out, and then you're left with 3x squared. I guess that's 12. Yeah, minus 12. And then you see, well, 3 and 12 share something in common. So then you also take out a 3. You already got the 4x out there. Now bring out the 3, and then you could have seen that originally the biggest thing that they had was a 12x. After taking the 3 out, just worry about what's left with here, and it's x squared minus 4. So that's the thing that would have been left here. Here's a 2-step way to do it, and here's a 1-step way to do it. I don't care how many steps it takes you. I just want you to get there. And here's the messed up thing about it. You think, okay, I factored out what they had in common. I did. I got the biggest one. I should be done. Type that into WebAssign or whatever this online homework system that we have is called. And it tells you you're wrong, and you get frustrated. And what do you mean, how can I be wrong? It's because this is something that we haven't talked about yet. It's called the difference of squares. We haven't seen something that didn't have all 3 factors. We saw how to factor x squared, and then an x term and a constant. We saw how to factor a quadratic that had all 3 terms there. Well, we didn't see how to factor a quadratic that just had the squared term and the constant term. We didn't see that. But here it is. It's called the difference of squares, where you have 2 things that are squared. I'll use A and B. And difference means you subtract it. A squared minus B squared. It factors. See, there's no middle term. The whole thing about O and I from FOIL, those are the middle terms. Well, this one's missing the middle term. The O and the I must have canceled out. One is going to be, in this case, a positive 2x. One's going to be a negative 2x. They're going to cancel out. Here's how it's going to factor, though. It's going to be as A plus B and A minus B. So that the middle term from O and I, outside and inside, is going to cancel out. Minus AB plus AB. They'll be canceled out. So you just have to recognize it. What helps you to recognize is that there's no x term. There's a squared term, and there's a constant term. No x term. So that should be a key to, okay, that means I can try difference of squares. Maybe this number, there's something special about 4. right? And 9, and 16. There's something special about those numbers. Maybe your number isn't one of those. Like those numbers are called what? 4, and 9, and 16, and 25. What's this list? What's so special about this list? Perfect squares. Right? You take a number, and a nice, counting number, a whole number, and square it, you'll get these guys, perfect squares. So when they're there, they're fine. We can see that. 4 is one of these guys. Right? You figure out what it is you square. What do you do? What do you square to get 4? It's a 2. What do you square to get x squared? It's an x. And those are the things that go in here. This factors as x plus 2, x minus 2. What this guy is, x squared minus 4, he's x squared minus 2 squared. So playing the role of A is x. Playing the role of B is 2. Okay. Now, just know that this guy doesn't have to be a perfect square. What's in front of the constant term, it doesn't have to be a square. But it definitely has to be a minus sign. Don't try this if it was plus. It doesn't factor. There's no way of factoring it when there's a plus. It's called the difference of squares for a reason. Right? It only factors when there's a difference. Okay. We'll get to cubes. Cubes are coming. Difference of cubes. But there's also something called the sum of cubes. But not for this stuff. Yeah. Questions?
You gotta bring down the 12.
I'm not done. Now, the final answer is yes. Like 12x times that. Don't forget that thing that you factored out originally. It's still there. It's not like it disappeared. It's still there. It's still on the outside. Good question. Good, thanks. Good catch. All right, good. Difference of squares. Okay. And it says factor completely. That's another hint about the word completely, is that maybe when you think you're done, maybe you're not done. Maybe there's an extra step in it that you have to factor further. So that's what that word completely means. All right. Good. Difference of squares. So if something recognizable, so maybe you need to make this list go out further for yourself. I won't make you take this list past 12 squared. Okay. There's other squares past 12 squared. Right? But you don't have to know those quick like that. And you can have a calculator anyway, but square root button on the calculator to any of these guys, and you get the whole number back out. But I just at least up to 144, right? 12 squared. Just 13 squared is 14. I don't expect you to kind of know those quickly, but if in a problem I give you something like x squared minus 81, I expect you to recognize 81 as 9 squared, and be able to quickly say that this guy factors to be x plus 9, x minus 9. Just that quick is how it's supposed to be. Okay. How could they make this more complicated? Maybe they could bring in fractions. Maybe they could put a number other than 1 in front of x squared. I'll show you that. Have something like 25x squared minus, let me get creative, I don't know, what's that, 49 over 64. This is worst case scenario. I like to give you a worst case. Can't do all easy problems. How do you do it? You figure out what do I square to get each of those guys? Like, who's playing a role of A and who's playing a role of B? They are both perfect squares. I just have to undo that. I have to figure out who's the thing that's being squared. It's not just an x anymore. Playing the role of A is not just x. Now that 25 is in front of there. So instead of an x, it's a 5x. Okay, so think about this as 5x quantity squared. And then over here, just if you have to, get a calculator out. Square root that. Maybe you don't know 49 is 7 squared and 64 is 8 squared. Maybe it's not that quick. That's okay though. You have to square root that. But the idea is that that's 7/8 quantity squared. So playing the role of A will be 5x. Playing the role of B will be 7/8. So when we go to factor it, we have 5x plus the thing and 5x minus the thing. And the thing is, that looks bad, sorry, it's 7/8. That's kind of worse worst case scenario. Some people get scared off by the fraction. Some people get scared off by the fact that there's not a 1 in front of x squared. I don't know what to do. Be like that. Difference of squares. So they complicate this by coming up with another one for cubes, which is pretty difficult to memorize. Difference of cubes. But we'll do that next. So still in section 1.6, this is kind of notes now. Still in 1.6. Finishing it off. We didn't get time to do this at the end of last class. So difference of squares is on our list of things to do. Now difference of cubes. So difference of squares is a squared minus b squared. And the difference of cubes is a cubed minus b cubed. Now, that list of squares, yeah, we can go up to 12 squared, but list of cubes, I don't expect you to be able to go past, I don't know, 6. I don't know what 6 cubes is. 36 times 6. 216. It's ridiculous, right? I mean, so 1 and 8 and 27, 64. Right, these are cubes, right? 1 cubed. This guy here, he's 2 cubed. This guy, 3 cubed. 4 cubed. You can't go too far. I can't make it go too much further than that. 5 cubed. That should be the limit. But just in case somewhere in the book, they might have 6 cubed. And I just think that's 216, I'm pretty sure. These are the little cubes. I really don't know much. That's the extent of your list of cubes memory that I expect. All right. 87 cubed in a moment? 343? Oh, wow. Sorry. If you have to use a calculator, 7 cubed. Wow. Sorry. All right. But the formula is not, so it was so easy, right? A plus B, A minus B. Right? You don't even have to think about it. This one starts off easy. That's weird. It doesn't even factor to be a binomial and a binomial, like an A plus B, A minus B. You have 2 terms in terms. It doesn't even factor like that. This thing factors to be a binomial, 2 terms, and a trinomial, 3 terms. Okay. So, I never memorized the words in the shop, but here we go. A minus B is the binomial. So keep the sign, okay? Right after this, there's going to be the same thing with a plus in between, but it's going to be a little bit different on the right-hand side of the words. And so here's what the trinomial looks like. I think it does an alternating on the sign. So there's a square, there's an AB, and there's a square. A square on the A, a square on the B, and there's an AB. And the sign is very strange. In fact, I'm just not trying to even have you memorize it, because I always make mistakes memorizing it. I just have it, have it written down for you. Maybe rely on some kind of small little cheat sheet or note card or something with obscure formulas like this. I still think I'm wrong. Minus and plus. I want a plus. I know it's a plus for the last. I guess we did that. See, that's why you remember. So you.
It's mine.
What are both of them?
I thought it was minus.
Yeah,
It's minus AB.
Minus 8. Look up. I'm sorry. No, I think I'm good.
It was right. It was right.
No, I think it was minus.
see it in action. X cubed minus 64. Who's playing the role of A? Who's playing the role of B? That's the question you have to ask yourself. Playing the role of A is X. Playing the role of B is 4. Okay, just plug it into the formula. X minus 4. Square the x and get x squared. Multiply a and b together and get 4x. Square the b and get 16. What'll always happen, you don't have to worry about this. You're done at that point. You know, normally you would think, I got this quadratic. Maybe I can factor that quadratic. It doesn't happen. It'll always be the case that the quadratic won't be factorable. You can't factor this any further. Like you always stop at that point. You're done. Okay? Same kind of things about how they can make it more complicated. It doesn't have to be an x cubed. It could be one of these guys in front of x cubed. It could be fractions. Okay? And then let me just give you the other formula with a plus. The sum of cubes. So it starts off as a plus b, and this is the one that has the alternating sign. It's a squared minus the ab plus the b squared. Sorry, my handwriting deteriorated here as I'm trying to speed up. Let me slow down. A squared minus the ab plus the b squared. There's no sum of squares. Please don't try that. But there is a sum of cubes. It just breaks down to be this formula. So 8x cubed plus 125 will factor. How will it factor? Who's playing the role of A? Who's playing the role of B? If it helps you, you can write them down. What do I cube to get 8x cubed? 2x. What do I cube to get 125? 5. And then plug them in for A and B. So I say it, I don't write it, but that's the first thing you have to think of. And asking that question and coming up with an answer. What do I cube to get this? What do I cube to get this? So 2x plus 5. Square 2x and get 4x squared. Multiply them together and get 10x. Let's put a minus on that. Square 5 and get 25. Sounds good. Questions? All right. Good. So I think we're equipped to finish off the rest of this now. They get a little extra with it here. This is difference of squares, but they have this extra step in there, a little bit too much. Anyway, we're good. That's it for I guess what this online book calls 0.6. So we're done with the first two sections officially. If you want to call them 1.5 and 1.6, that works out. As a student, I don't know why the order of this is what it is. As a professor, I think I see them in order that I put them in. Yeah. So we're done these two. Then the book takes a few things after that, but we're skipping those, and we jump to talk about 2.1, which is solving linear equations, solving an equation, basically. You know, your normal type of equation that you would think of. That's what 2.1 is talking about. How do you solve an equation that only has an x in it? All right, solving linear equations. That's in the online text. That's called 1.1. when they go through some definitions, I mean, I don't want to talk about this, but yeah, there's a difference between an equation and an expression. What does it mean to solve? You know, there's all that there. But I just want to do examples. You know, I just want you to sort of start off simple and get more complicated. And so simple would be things that you can do in one step. This isn't talking about lines, graphing lines. I know it says linear, but that's coming later. What we're talking about now is just solving equations that have x's in them. Maybe it's a simple thing like, 5x plus 3 equals 7. Something simple. It could get more complicated as you quickly see with some of these exercise problems here. Let me just grab the whole lot of them and pick some at random. Some are simple. Actually, some you don't even have to do any steps for. Some you can do mentally, and I'm okay with that. Right? Number 17, right? The question that's being asked is, what do I add to 10 to get 15? If you just, write the answer down, it's okay, right? 5. That's the answer to 17. There's nothing to write down. But when it comes to something like 19, maybe you can't reformulate that question in your head well enough to be able just to spit out the answer. So there's some work you have to write out. Let me go ahead and take a picture. This thing can take a picture of the screen, and then automatically put it to that system there, that notebook system. It's pretty neat. Oh, that's annoying. Let me make it stop doing that. All right, here we go. Anyway, yeah, so something like 17, I wouldn't even, have any, maybe 9, maybe 18 is difficult mentally. The whole point is you have to solve for x by doing the opposite of what's being done to x. 7 minus 2x is equal to 15. Do the opposite of what's being done to x. Like get x by itself. But maybe you just look at it and say mentally, okay, what do I add to 7 to get 15? I add 8 to 7 to get 15. Well, this guy here, he must be an 8. And so minus 2x must be an 8. Maybe x is negative 4. Maybe you can do that. I don't expect you to be able to do that. But some people are quick like that. That's fine. After a while, though, that's not going to take you too far. But it's cool if you can do that. Right? 7 plus something is 15. That something must be 8. If negative 2x is 8, then x is going to be a negative 4. Right. But here's what I want you to be able to do. Move things over. Isolate x. Right? Get x all by itself. That's your goal. So undo what's being done to x. But there's a certain order into how you do that. Okay? Yes, x is being multiplied by a negative 2, but after that, there's something done after that. This 7 officially actually is being added to both sides. And so basically, we do the opposite operation. We need to isolate x. We need to undo what's being done to x. And how we do that is by doing the opposite operation to both sides. Right? You can't just do it to one side. It's an equation. In order for it to still be true, you have to do it to both sides. Okay, so this 7 here. If I'm going to isolate the x, I have to get rid of this 7. I have to also get rid of this negative 2. Right. Get rid of it means I need to make it not there anymore. How can I make 7 disappear, go away from the left-hand side? Well, the only way it's going to be zeroed out is if I take away the 7. Or whatever I do to one side, I have to do to the other side. Officially, that's me moving it over to the other side. That's me getting rid of it. It is no longer on the left-hand side. I took it away. It leaves me still with something there, but it's less than what was there before. I'm only one step away from getting the answer now. But just remember, when you do one side, don't go and try to do the opposite to the other side. Do the same thing. You have to balance out. If you take away 7 from one side, take away 7 from the other. So you're going to make positive, negative, integer arithmetic is going to be a major issue here. Right, we're going to have negatives, negatives, and negatives, negative, plus negative, negative, minus negative. You have to be careful. But anyway, if you're careful on how you write it, then it makes it really easier. Carry down things that don't change, right? Remember your equals. Don't make a careless mistake if you get a negative sign. Okay, and now what's being done to x is it's being multiplied by a -2. Opposite of multiplication is division. You need to divide by a -2. So you do the left, you do the right. Don't just divide by 2. That won't be getting it all by itself. In one fell swoop, we get it all by itself by dividing by a -2. Okay, don't make a mistake here. Just say real quick, making a simple, error to say that x is 4. No, x is a -4. And once again, you can check your work. I try to pick problems that come out to be nice integers, positive and negative whole numbers like this. It's really messed up when you're having something like 427s as the answer, right? So the chances you're going to go back and check that. So on exams, at least, the problems that I pick will be nice integer values. I can't say the same for some of the homework. I try to find homework a little bit like that, but at least maybe the fraction is halves if there's a fraction involved, thirds, but nothing like 7s or anything like that. So all they do is just add more layers on top. This was a 2-step problem. I did 2 steps. I took away 7. I divided by -2. 2 steps I was done. So all they're doing by taking and throwing all these extras, they're just putting more and more steps on top. Eventually, all these problems end up boiling down to a 2-step and then a 1-step. So if you can get 1 step and a 2-step, then you just build layers on top and don't be turned off by this. Like, so what, this problem has all the parentheses, square brackets in it, number 26. So you can do it, just take your time and just follow the order about how you do it. Let's take a look at it. 26. I'm going to say to yourself, why am I just don't give up. Right? Effort is big for you, so try. Right? That's big. And you're not gonna, if you show up to class and you try and show some effort, you're not gonna fail the class, no matter what. All right, let's take a look at 26. 3. Then I see a square bracket, 2x. I know it looks bad. I mean, it's ridiculous. I mean, why add all this extra stuff on it? It's overkill. Right? So what? It's just a test to see if you can not keep up. That's how I look at it. This is ridiculous. Like, this is 7, 8 steps. Eventually, we'll get the right answer. Right, do it on your own, as I'm doing it, or do it at my pace, however, whatever it takes. Make sure you get the same answer I get. Do your own steps. If you think that you should multiply this 3 across first, then do that. I wouldn't, but if that's what you would do, then do that. If you see 3 on the outside and you think, oh, let me put that 3 in, go with that. What I'm going to do instead, though, is I'm going to fix up that square bracket first and get it as simplified as possible before putting the 3 in. But that's just, it's a personal preference thing. You never have to do the problem the way I say you do it. So as long as you get the same answer, that's all good. All right. I'm going to distribute this negative sign and then simplify those terms. So that means I'm going to get a -x and a -7. Never did anything to the 2x. So I leave it, and now put together like terms. I kind of like doing order operations, right? Fixing up this grouping, fixing up the parentheses first. But not really officially order operations, though. 2x minus x, these are both x terms. They can be combined as an x. Still got this -7 that I didn't combine with anything. I'm not going to make a mistake called it +7. The most common mistake that's made in these is when you go to distribute and you never distribute across to the second thing. You just write down what the second thing is. So if the student's going to make a mistake, I would say 80% of the time on this, it's in the very beginning when they're going really fast and they say -x, but they don't say -7. They say +7. Distribute to both of them. It helps draw an arrow. I don't know what happens. All right, now this is the new square bracket, simplified, ready for you to do something like put the 3 in. do 3x, distribute, and then 3 times negative 7, distribute that. I want to draw the arrows up top, so I can follow here. And I haven't even touched the right-hand side. I mean, I can at this point. I probably can. It might be best to go ahead with the right-hand side too. But anyway, we get 3x minus 21. Let's go ahead and, you don't have to keep copying this stuff down. It's fine. I'm not really, anal like you have to have a certain looking way. I mean, I just want you to solve the problem in here somehow. To show some work along the way, so I can try to find a mistake and give you the credit that is due if you make a mistake. Sometimes it's very difficult if you just write things all over the place. I won't look at it if it's like a puzzle to try to put together, scratch outs and all that. I just go on to the next problem because I got 40 students, so I can't sit in the 20 minutes, 3 minutes with one problem trying to figure out what was going on inside your head as you just put stuff all over the place. So the neater the better it is, and the more chance that you'll get a chance to get extra credit. Or not extra credit, the credit that you're due. So, you'll get extra credit. All right, 5x minus 15. Is this going to be a whole number or a nice integer? Yeah, we're good. Okay, so we have now what's different about this is that there's an x on the left-hand side and an x on the right-hand side. Oops, that's okay. Put them together. So, and it doesn't even, you don't have to always have the x's on the left-hand side like you used to. So if you feel, I feel actually it's better to have this x being on the right-hand side. I want to avoid negatives. I forget about them, I make mistakes with them. I could take away 5x from both sides, no doubt. That's me always wanted to have the x on the right-hand side, left-hand side. So I don't care. I would rather move this over here though, so that I'd rather have it as a 2x and not a negative 2x. I have to later worry about maybe making a mistake and getting that negative. So I would take that guy and move him over there. And then take this thing over here and just shift it over to the other side. But don't take it away. Don't think that you always have to take stuff away to move it. You got to do the opposite operation. It's being taken away. So you need to add 15 to both sides. You can do it all at once that if you want, as long as you're careful. So negative 3 then? Sorry, over talking, I talked too much. This is like out there. Hopefully I was useful to somebody on that talking. Good? X is negative 3. Check it if you want. You have time. Later on. Alright. And I mean, yeah, alright, so what? They have decimals, they have fractions. Alright, what's that really adding to? It's more time. But the steps are the same. Undo what's being done at X. Group stuff together before moving it over to the other side. Okay. I was on 6:45. Sheesh. Time flies, huh? I got this thing in my hand. I won't torture you anymore. Maybe one more. But a fraction. Like fractions everywhere. Like on the next page here. Yeah, it's kind of crazy. Fractions everywhere. Let me pick one of these and we'll be out of here. I don't know. Pick one. You guys want to pick one? You don't care? You want me to pick it? Pick the last one because it always is the hardest one? All right, I'm down with that. I don't like that one. Wow, that's crazy. Let's do it. I mean, there's more after that, but enough already. Let's just do this. So, anything that we don't do here, try. Don't just do the web homework. I mean, I think you should, definitely do that. But then for extra practice, just do exactly what we're doing here. You should be able to do any of the problems that are in the exercises up to a certain level. So you should be able to do this. Blow it up. All right. So it's just extra steps. The way I would start this might be different than the way you would start. And there's a long way and a short way. I think that by the fact that they say 3u plus 1 in both those denominators, that's a gift. Take that gift. Use it. Save yourself some drama. don't try to put, don't forget about this guy. Like, don't like forget about the right hand side and try to work with the left hand side. I don't recommend that. I mean, yes, common denominator, yeah, putting together that might work and everything, but no. I say that we can first do a simplification by putting those two guys together. It's a full term itself. It's 6 over 3u plus 1, and 15 over that same 3u plus 1. Same denominator, that's a given. Shift it over. Take it away. It's being added. Take it away. All right, so, I don't know, side by side, up and down, however you want to do it. Take it away from both sides. It gets rid of it from the left. It's now gone. And it's simple to put the two together because they have the same denominator. It's nice. And the fact that they just have numbers in the numerator, that's also nice. 15 take away 6 is 9. That's your numerator. 9, oh boy, try again. Over 3u plus 1. What's left on the left hand side? 4 over u minus 1. Yeah, I don't think I can do that. I don't think I can figure that out. Hopefully, I would like for it to be an integer. I can't assume that though. So we're going to go ahead and attack this by the fact that we recognize fraction equals fraction. This is back when we were setting up ratios and proportions, right? A fraction is supposed to be equal to another fraction. That's the ratio, not the proportion. So then we can cross multiply when there's an equals in between. If there's a times in between, then we're talking about cross canceling. We're not doing that. Equals in between two fractions, cross multiply. Numerator of the one side times denominator of the other side should be equal to the opposite. Sorry. Technical difficulty. What the heck is this? Oh, whatever. Ah. What happened? What is this? Hey. Whatever. Alright, we're just going to finish it. Get out of here. 3u plus 1 times a 4. If you want to do it in the end, you can. I'm going to go ahead and write it out. And 9 times a u minus 1. So sorry. We can finish this out. If you want to do it in your head, you can. Here's a common mistake, though. Yes, you do 4 times 3u and call it 12u, but you forget 4 times 1 and call it 4. 9 times u, yeah, that's the one that's obvious, but less obvious is 9 times negative 1. Sorry about that. I don't know how you figure that. I don't know how. That's not good. Not that's okay. This guy over to the other side. I don't know what's going on with this. We'll just finish 12u plus 4, 9u minus 9. This guy over here, taken away. To leave you with 3u. This guy over here, taken away. Be careful. That's a negative 13. All right, we just won't have to check it. That's okay. If it's on the test, though, and you see this, you should think something's wrong. Because like to have positive or negative. So you check your work. U is negative 13 thirds. I don't like it, but whatever. All right, see you guys later. Oh, now it goes away. That's a 3, that's not a 7. All right. Well, yeah, what's your last name?
Prendergast. P-R-E-N.
Okay. Prendergast?
Gast, yep.
Tim. Syllabus. We're almost done with this first bit of material.
All right.
We'll have a quiz on it. Maybe that day, maybe we'll move it.
So
We'll see.
all right.
And
just get the
now that you're registered, you're on D2L. You don't have to buy the book in the bookstore. If you you have to buy D2L. You have to buy this homework system. It's called WebAssign. And you can, like, if you get it by itself, or you can pay an extra $30 and get the book on the computer. So
Right.
so that's $80 as opposed to, I don't know, $150 or something that they're charging.
Ooh, okay.
Yeah.
I'll do that.
I'm not supposed to, you hear it from me. I'm not supposed to say
Got
that.
it.
That's inside information. But you gotta get this at least, because that's where all the homework is at.
All right.
All right.
All right.
And on D2L is how to get logged into it. So as soon as you're registered, you can get the D2L.
Great. Thanks a lot.
All right, Tim. Yeah, take it easy. They tried to yank me from this class. I got a phone call that said, we want you to teach stat. I'm like, well, who's going to teach this? Oh, we'll put anybody in this class. I said, I don't know. It's a smart idea. Oh, yeah, late. Okay, I mean.
Gotta watch it.
B. Got it. Okay, gotcha. And Nikki?
Yes.
Did you miss on Thursday, Nikki? I got you missing. You did miss?
Yes.
That's okay. I just want to make sure.
I moved in here.
I know it is. That's cool. Okay.
I have a question about homework.
Yeah, let's do
Quick.
it. We'll do a little homework.
Yeah, I thought I had the answer, but on the website it's not coming up as the right answer. It's a factoid grouping.
All right, let me do it. Let me do this. Let me pull up your version. I can do that. Let me go. Let me turn off this recording.
Everything I got so far